Evening. Today I am here to present my thesis work. My title of the thesis work is the computer vision and deep learning for drone detection application. Drone is mainly used in the defense industry, aerospace industry, and smart city surveillance. So it have a wide application. It have the application in the logistic also, in the agriculture also. So it have a very wide application. It's a very interesting topic. So that's we selected this computer vision and deep learning for drone detection application. And within topic is very good, but there are some security breach and some risks are also there. To minimize the risk of security failures, we have to detect the object correctly, and to detect the object correctly we selected two models, YOLO V8 and DETER 8. In we choose the data from the social platform, Kaggle platform. We already provided the link for the data, and that data is customized into small data set that is consist of 5728 image. In that 5728 image we divided the data into training, validation and testing. Training consists of 12% validation and 4% testing set. In data, first we did the customizing of the data, cleaning of the data, labeling of the data. We check the missing of the labels, and then we did the annotation. We give the size of the image 640 into 640. We tune the parameter. We fix the threshold weight 0.25 we have taken. So these are the different processing step or auto augmentation, data augmentation to increase the robustness of the process. And these are the different steps, tuning of the hyperparameters we did in the YOLO V8 models. In DETER also we did the analysis, tuned and untuned. Both we tried it in the analysis. Performance metrics we have taken to check the performance of the models. Precision recall MAP 0.5, MAP 0.5 to 0.95. Tune deter we did for the 5 approaches, and we changed the dimension of the image. We changed the resolution of the image. We changed the weight of the cocoa to increase the to get the better performance of the DETER model. But compared to the YOLO model, performance of the DETER and tuned DETER is very poor. We will discuss later. So these are the performance metrics we have selected to analyze the performance of the models. This is the complete flow chart of the process: data set preparation, pre-processing, augmentation, YOLO V8 for 10 approaches, and tuned DETER for the 5 approaches, evaluation parameter as we already discussed, and comparative analysis. The YOLO, the mathematical functioning of the YOLO we can see in the slide. First we did the input image. 3.7 equation indicate the image input, and f theta is the YOLO V8 function. Theta is the weight of the function. Xy is the coordinate. WH is the image dimension. Ci is the labeling of parameter, and Pi is the weight. Backbone feature extraction based upon the CNN, and multi-scale feature fusion. Then anchor free detection head, we update the coordinates. Loss function, loss are consist of 3: regression loss, classification loss, and DFL loss. So we have to minimize the losses. This is the same working of the DETER methodology, but here we are using the RESN50, that is the backbone of the CNN, and positioning, transport, encoding, and these are the objective, query, and decoder to predict a set of the object in the parallel. Hungarian match and loss functions. And tuned DETER model, we refine the resolution, we refine the weight, and these are the different steps we have taken to for the tuning of the DETER model. Result and discussion. In result and discussion, we first compare the performance of the YOLO V8 model for the training, validation, and testing set. Then YOLO model performance is compared with the DETER model. Then DETER and tuned data performance is compared, and finally we compare the performance of the YOLO model with the tuned data. As we can see that the loss figure 5 point indicating the loss of the training and validation. It's showing that precision is continuously increasing for the training and validation set, but recall is falling. It's showing that prediction is model have the better tendency to predict the correct to detect the object correctly, but there are some decrement in the recall value, and it indicates that there are possibility of the missing the objects or identification. This is the PR curve. Below the PR curve indicating the performance of the model. It is drawn for the training, validation and testing, and this is the performance metrics, MAP and precision recall trends with the reports. Impact of the confidence threshold, we have taken 0.25, so that we have taken 0.25. During the process we observe that we have to define the confidence threshold weight as the recall value is decreasing. So this is the confusion matrix. What we did the comparison of the YOLO validation, training, validation and test set. As we can observe that for the training 0.619, and for final validation 0.69, and for the testing 0.64. It indicates that model is able to detect the object correctly, but in the testing set it's decreasing. Mean there are some generalization gap is there, some overfitting is there. The recall value is continuously decreasing, mean there will be some misidentification or some objects are not identified properly. And this is the plot for the YOLO model. Then data result is showing that all the value of the performance metrics are coming near to zero. So it's showing that the model is not able to detect the object properly, so that we have to proceed to the tuned data model. In tuned data model we did the tuning for the pi epochs. We observed that tuned data model is showing better performance than the untuned data model, but still the improvement is very less. Mean we observe that the less number of the epochs we have taken, 5 epochs we have taken, minimum more than 50 epochs we have to take. Data set is less, we have to increase the quantity of the data to get the better performance of the data model. And data model is able to not properly able to detect the small object compared to the YOLO V8 model. This is the performance comparison for the data and we fine tune data. This is the comparison of the YOLO V8 and with the tuned data. As we can observe that YOLO V8 model is performing 300 times better performance than the YOLO V8 model. Finally, we are going to conclusion that YOLO V8 model is able to detect the object correctly, as we seen in the metrics that precision value coming 0.601 or 0.69 for the training and validation, but decreasing in the testing set. Mean model is able to detect the object correctly, but there are requirement of some generalization. We need to improve the generalization, but model is giving the good result for the prediction, but still there are some misidentifications of the objects also there. And data model is showing very poor performance. Data model is not able to detect the object correctly. So for this current task, YOLO model is the best model to detect the object properly. Strength of the analysis, well, we organize the data properly. We check the compatibility of the YOLO V8 and data models. We observe that threshold have a very significant influence. We compared with the data model, we address the real world problem. It provides the insights into the generalization, class imbalance and small object challenges. Limitation, we did the analysis for the less number of the epochs, data size is less. We need to improve the generalization. We need to increase the quantity of the data. These are the limitations. Future scopes, these are the future scopes of our research work. Thank you very much.